Okay, now we go to fundamental problem F91. Here we have this curve, okay, this boundary curve, y equals to x cubic, and this is x is y, and of course the point here is 1 1, okay, and the question asks to find the centroid x bar y bar of this region, sorry, this area, okay, this shaded area. So to do it, first you remember that we talk about we have to find the the differential area, dA. We can do this by actually we select one point on the curve, okay, here for instance, and we name it as x and y. I mean, of course, everything is x and y here, you know. Select one point, we make differential area like this, and then make it a bar, okay, differential area. Why we call it differential area? Because now if you do like this and we choose this horizontal differential area, what we have is this is x, right? And this thickness we call it as dy. Okay? And then we need to find the centroid of this cross-sectional area. Sorry, the differential area. So the centroid should be somewhere in the middle here, right? And this centroid is given as what? X tilde y tilde, right? What is this x tilde here? X tilde is actually it is the it is x over 2. This is 0, this is x, so x is in the middle, so it is x over 2. How about y tilde? Y tilde is actually y. Y tilde is this, and this is y, right? So why we want to do something like this? The reason is because when we want to find the centroid, the formula is given as x bar equals to integration over the area, because this is area, right? You have x and y, this area. X tilde dA over integration over the area dA. Okay, so that's why we need this, and the y will be like that. I mean, y tilde dA and the rest. Okay, so again, actually the question asks to find where is this x bar, y bar, the coordinate of the centroid of this area. Okay, so we put it into the equation for x bar. So x tilde is x over 2, right? Okay, another thing, dA, what is dA? And dA is differential area of this, which is dA equals to this times this, right? So x times dy, x, the length, and then the width, and the thickness is dy. So we put into the equation, x tilde is x over 2, right? dA is x, x dy, right? So integration of this will be integration, because this dy, as you have chosen this horizontal line, horizontal bar, horizontal area, so it will be dy. So if you have chosen dy, then you need to take the differential from this point to that point, which means that y equals to 0 to y equals to 1, right? Because this is dy, differential over y, over integration over area. So integration again, dA is x dy, and area is the boundaries are 0 to 1. Okay, how to do this integration? So basically we need to substitute this x in terms of y. Okay, so x bar, continue, x bar equals to 1 over 2, take the half out, and then integration from 0 to 1. So this is x squared, right? X squared, so x squared will be y power of 2 over 3 dy, right? And the bottom one will be 0 to 1, okay, and x is y power of 1 over 3 dy. What is this? This is math, so go back to maths, right? This half into integration of y power of 2 over 3 will be y power of what? Plus 1. Plus 1 will be 5 over 3. So it is 5 over 3 y power of 5 over 3. And okay, this is confusing actually. Just do this. And it is from 0 to 1. And then for the bottom one will be plus 1. You integrate y power of 1 over 3. So plus 1, so it becomes 4 over 3. Right? So 4 over 3 y to power of 4 over 3. Again, how to do this integration? You should have known this. Okay, it's not, this class is not to show how to do integration. If you find yourself struggle to understand or to follow this, you should go back to maths and to look at on how actually it is done. Okay. Okay, so 1 over 2. Top one is 3 over 5. Bottom one, the bottom one is 3 over 4. Okay. So what happened here? 2 over 5 over 3 over 4. Even myself got confused, but that's fine because if you substitute 1 here, it will become 1. 1 of 3. Okay. So it becomes 3 over 5 times 3 over 4 here. Becomes this 2 over 5, right? So 2 over 5 is 0.2 meter, right? Sorry, 2 over 5 is 0.4. 1 over 5 is 0.2. 2 over 5 is 0.4 meter. Okay? So this is your y bar. How about your, x bar? How about your y bar? Y bar is integration over the area y tilde dA over integration over the summation. Integration over the area dA. Yeah? Y bar is y. So integration from 0 to 1. Okay, just follow the previous step. Y tilde is y. Okay, dA is x dy, right? And integration over 0 to 1, x dy, and then becomes 0 to 1. Y, x is y power of 3. Y power of 1 over 3, right? Dy, integration over 0 to 1, and x is y to the power of 1 over 3 dy. Okay, so your y bar is y times y power of 3 is y to the power of 4 over 3, right? Let's try it. Y to the power of 4 over 3 dy over integration over 0 to 1 y to the power of 1 over 3 dy. Okay, let's do integration. So this is 4 over 3. Integrate that, plus 1 becomes 7 over 3. Okay, y to the power of 7 over 3, right? And then here it becomes 7 over 3. Okay, this is from 0 to 1, the boundaries. And the bottom one, y power of 1 over 3, if you integrate that, it becomes plus 1. It becomes 4 over 3, so y to the power of 4 over 3, okay, from 0 to 1. And the coefficient will be taken out, 4 over 3. If you substitute 1 and 0, it becomes 1, both in the bracket, these two brackets, okay? So now it becomes 3 over 7 times 4 over 3, okay? So you have 4 over 7 here. So y bar equals to 4 over 7 meter, or 4 over 7 is 0.571 meter. Okay, x bar, y bar. What does it mean by that? It is somewhere here, 0.5, so 0.4, right? Somewhere here, and then 0.1, 0.571. So it is actually this. I mean, you can roughly you can say that this point is your centroid, right? This is x bar, and this is y bar. Okay, this coordinate, right? So this is your the centroid for this problem.